Hi, my name is Dana Golden. Today we're going to go through our introduction to Python. I'm going to be teaching the coding parts, and Jiaoshu is going to be teaching the math parts of this course in machine learning and data science. So let's get started. So what is Python? Python is a general purpose, object-oriented, high-level programming language, and what that means is that it's very versatile. There's a lot can do. There's a big community, and you can create classes. It's structured around functions. So it's a lot easier to write in than Java. It's a lot more useful than R or Stata. And it's a lot further from being strict machine code than either C or Fortran. It's valuable for rapid application development and quick scripting. So if you need to start today and have an application very soon, Python is really a good way of doing that. It's a quick edit debug cycle that makes for high productivity. So instead of having to write large bits of code, sort of like a waterfall, you can edit debug very quickly, and you can quickly move towards having a functional product. It has an incredibly active program community that gives a strong, incredibly active programming community that gives a strong base. If you want something implemented and it's not new to the literature, it's probably been implemented in Python. So why Python? So this is a valuable question. It's kind of ruling the world. It's a bit questionable why it started ruling the world. It's an odd language. It's not database oriented like SQL. It's a lot harder to learn than certain programming languages, and it's a lot slower than Fortran or C. But it's a lot more useful than Stata or R. And it's a lot more general purpose. Very good for data science. Has a massive community of developers working on code. So much of the code has already been written. You don't have to worry about looking up a error message and not finding it. It's you have that community already. Can do pretty much anything. There's an extremely low barrier for writing code compared to some other languages. That's the default programming language for machine learning. So you can find basically any machine learning stuff implemented in Python. Drawbacks of Python: it's computationally slow, not for scientific computing. There's a higher barrier to entry than either Stata or R, particularly for certain types of econometric modeling. If you're just trying to analyze some data off the start, you might find it challenging to implement panel models or some linear regressions in Python compared to Stata. But it's going to be a lot easier to manipulate the data. It's going to be a lot easier to do more complex stuff. Obviously, it's not SQL, so it's not ideal for database tasks. It can cause problems when used without strong understanding. It's going to be a lot harder to debug than something like Stata. And it's computationally slow. It's not for scientific computing like Julia or Fortran. So types, a type in a programming language is basically the building block of what the programming language sees. So a float is a number that has a set number of bits of precision. An integer is a number that is that has no decimal. A string is a set of characters, and it's not interpreted as a number or a float or integer, and a Boolean is a true or false value. So here's some data structures. Those are types. Data structures are to take the form of a set of types stacked up on each other. So list, here's a list. It's a bunch of things held together in a certain order. Here's a tuple. It's very similar to a list. here's a dictionary. A dictionary has a set of keys and values. You have the key here is Dana and then TA, because that was the TA in a previous iteration of the course. So if you did dict of Dana, you would get TA. And then sets are like lists, except you only have one of each value. So it's unique values of a list. Lists are orderable, ordered, changeable, and allow duplicate values. Lists are indexed at 0. So you have a set of values you can directly get from the list. You can add to list using append, and you can take from the list using remove. And list of, this should say 0 gets the first item in the list. List of 1 gets the second item on the list, because they are, again, indexed from 0. Dictionaries connect individual keys to value, allows you to link and create mapping tables. It's useful for creating trees and more complex data structures. So you create a dictionary of a key. You can say dict of key equals value. You already have to have the pre-existing dictionary. So variables are assigned in Python using one equal sign. Quality is checked when there are two equal signs. So if you do x equals y, it will check for equality between x and y. Here we have x equals true, print x, and then we get true. And then if we do false equals true, we'll get false, because false is not equal to true. So here we have operators. X equals 100, y equals 200, x plus y equals 300, x minus y equals negative 100, x divided by y equals 0.5, x times y equals 2000. Here this should be x equals y, and that's false, but x does not equal y. That's what this factorial, or this exclamation point equals means this does not equal, and that's true. So mathematical functions, math.ceil hits the next highest integer, it rounds up. Math.floor rounds down to the next lowest integer. Math.factorial finds the factorial of a value. Math.log takes the natural log of a value. Math.exponential takes the exponent of a value. And random.randint generates a random integer between two numbers. So if statements, these are very important in programming. If you haven't taken any programming classes before, these are extremely useful. So if statements allow you to perform operations only if certain conditions are met. It's useful for handling edge cases. So if x is less than 200, print high, and then it prints high. This is supposed to be a less than right here. So if x is less than 200, print high, and it does. For loops allow you to iterate over a set of objects to perform an action over a certain number of times. So here, for I in range 10, it does it from 0, 1, 2, 3, up to 9. And for I in list, it does it for objects in a list. While loops perform certain tasks while certain conditions met. Here, this is also supposed to be less than. So while x is less than 200, call x equals to 100. You do x equals x plus 10. So you always want this to have a condition in the while loop that will lead to its termination. So in this case, it terminates after 10 times, and it prints 110, 120, 130, up to 200. Really up to 190, because it stops if x is equal to 200. Functions start with define arguments. So you have define, and then you have the set of arguments, and then you have a colon. Functions have keyword arguments and positional arguments. Functions allow you to reference different tasks that you do routinely or build more complex routines. And finally, in our little introduction to Python, when installing Python, you want to add Python to the path so that you can directly reference Python in the command line. Though in this class, you're heavily encouraged to use Colab. So instead of installing Python and adding Python to the path, just go to Google Drive and use Python through Colab. And then you want to use pip to install package to install packages from the command line. In Colab, you're going to use !pip to install a package. And to use a package, just import the package. That's our little introduction to Python. I would encourage you to also look at the corresponding collab notebook and the corresponding video that goes with that collab notebook. But for the deal, I'll see you next time. Bye.